Okay, so now we're back here, we're looking at examples. Let's start with number 1. The directions say, which postulate would prove each pair of triangles similar? Write a true proportion based on your similarity statement. So there's really two parts to this. The first part is, are the triangles similar? And then the second part is, let's actually write down triangle blah 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 is similar to triangle blah blah blah. Alright, so here we go, number 1. You're still looking, when it's for angles, you're looking for congruence. When I see parallel lines, I start looking for z's. There's a z, so those two corners are congruent. Those are alternate interior angles. We have another z, a backwards z. Those are going to be congruent. And actually at this point we're done. Right now we have two sets of corresponding angles congruent. That's angle, angle, similarity. Now could we also add in the vertical angles? Yes, we could. But you don't need to because you already have two sets of angles congruent. So this right here, angle, angle, similarity, that's your postulate. We could say that triangle ABI is similar to triangle. Now I have to match this up correctly. A matches up with L. Those are both two arcs. B matches up with F. Those are one arc. And then I matches up with itself. Triangle ABI is similar to triangle LFI. Now it does say in the directions, write a true proportion based on your similarity statement. Here's the similarity statement. So the true proportion would be AB, which corresponds to LF, now these are the sides, would be proportional to BI over FI, would be proportional to AI, that's the first letter and the third letter, and then LI. That would be a true proportion right there. Okay, so let's take a look at number 2. Now number 2, do we have any congruent angles? We do. Here where these two lines intersect, we have vertical angles. Now notice that the other thing that they give you is side length. They give you 12 and 10 in the top triangle, they give you 5 and 6 in the bottom. How do I know how to try to match these? I'm going to try to make not a proportion, but two fractions. Well, the biggest side 12 would have to correspond to the biggest side 6 in the bottom triangle. So the 12 would go with 6. It wouldn't go with the 5 because 5 is smaller than 6. So I have to match up the largest sides, and then I'd match up the smaller sides, 10 and 5. Now actually, those are equal. If I divide that, both of them equal 2. So that means that they're proportional. So if I look at the top triangle here, the way that I'm going to label this, I'm going to say 12 and 6. And I'm going to put a little slash right here. These are not congruent, but they do correspond. So that's what the slash represents. I'm going to put 2 marks here, 2 marks. I'll put a little slash through that one again. This is not an official way of marking it. This is just how I show they're not congruent, but they are related to each other. And what we have here is a side, and then we have the angle between them. So this is side angle side similarity. And the statement we can make, we can say triangle WZG is similar to triangle, now the W would go with the H, we go W to Z, so it would be H to B, and then G. Now we could write another proportion. We could say WZ over HB equals ZG over BG equals WG to HG. We could match that up. Those would be proportional, those 3 fractions right there, those ratios. All right, so that's number 2. Number 3, they don't tell us any side lengths. Now that's one thing. This gives me a clue here. We're probably not going to use side, side, side or side angle side similarity because we don't know anything about these lengths. I don't know that they're proportional. What we do know is we have parallel lines. Now parallel lines, a lot of times we look for the Z. The Z shape is always congruent with parallel lines. You can also look for a C shape where these angles here, they're not congruent, but they're supplementary. Now that doesn't really help us in this case because we want things congruent. We want angles to be congruent. But the other thing you can look for is this F shape. And what happens is the angle at the top of the F and then this angle here at the bottom, those are congruent. Those are called corresponding angles. And you'll see that a lot with similar triangles. We would have, this is like a backwards F here, or upside down F. Those two are the same because they're in the same position. And then angle DXP and angle DSR, they're also in the same position, just parts of different lines. So with parallel lines, those are the same and those are the same. Both triangles share angle D, so that would be a common angle. But right now we're done. We can write this angle-angle similarity. That's enough. And now the similarity statement, we can say triangle DPX is similar to triangle, now let's see, D would correspond to itself. For the big triangle, we got DPX for the small, DRS for the big. And I'm not going to write the proportion. Okay, I think we're all right with that. The key is really you've got the similarity postulate, and then here's your statement for the triangles. So that's another example of angle-angle. And now we have one more problem here. We have number 4. Now number 4, they don't tell us anything about angle measure. We don't have parallel lines because the triangles are not together. But they do give us side lengths, all 3 side lengths in both triangles. So what we'll try to do here, let's match this up. Let's say the 12. 12 is the biggest side in this triangle AYD. The biggest side in triangle HON is the 8. So those would have to correspond. Now the middle side over here is 10.5. And the middle side here is 7. And then the biggest side, or sorry, the smallest side here is 9. And the smallest side here is 6. Question though, are they proportional? Well, this is where we would take a calculator. Let's go ahead and type these fractions in and see if they're the same. 12 divided by 8 is a decimal, 1.5. 10.5 divided by 7 is 1.5. 9 divided by 6 is 1.5. So what that tells me is that all 3 ratios are equal. That means that these sides are proportional. So this is side, 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 similarity. Now, when we match this up, if I say triangle, I'll go ADY. Triangle ADY. So A to D, that was the longest side. So that's the 12. That means I'm going to have to start here with the 8. Now do I go HON or do I go OHN? Well, let's see here. We went from 12 to 9, ADY. So I'd have to go from 8 to 6. So OHN is how I would match it up. So what I'm saying is that A goes with O, D goes with H, and then Y goes with N. Okay, so those are the 3 postulates: angle-angle similarity, side-angle side similarity, side-side-side similarity. That proves similar triangles, and that is the end of the notes.